So you have these nets here. Again, these are the 2D representations of these 3D things. Okay? So, for Roman numeral number 1, I have this. It's got a square base and a bunch of triangles around it. So what shape does that match with? Which letter? C. Good. These are pretty straightforward, right? All right, what about number 2? Which one? E. What about 3? A. A cube is a square prism. Square prism. Right? It's all squares. What about 4? Thank you. And 5. C. No, not C. Yeah. D. You have 4 triangles making a 3D tetrahedron. FYI, tetra is a prefix for 4. That could maybe help you on an SAT one day. Those prefixes are cool. All right, so let's make a quick distinction here. You have 2 kind of weird, similar things, and oftentimes I say them incorrectly, okay? You have pyramids and you have prisms. When you think of prisms, you think of rectangles, something like this, okay? But they can also have triangular faces. So I want to tell you a distinction between pyramids and prisms. And forgive me if I make the mistake and mix them up in my brain. All right, a pyramid is all triangle faces. So an example of a pyramid is this tetrahedron. So it's mostly triangles. Okay? So here's another pyramid. It just so happens that it has a square base. And here's another one. It's got a pentagon base. This one is also a pyramid. Okay? Now, prisms have mostly rectangular faces or square faces. So see how these have a triangular side? They have 2 triangular sides, but they have more rectangles. This one has 1, 2, 3 rectangles. This one is the same. So despite having triangles, they're prisms because they're mostly rectangular faces. Okay? So I want to make that distinction because it can be somewhat confusing. So make sure when you're using the formulas, especially volume and whatnot, that you have the difference down. Okay? So moving along to the next topic, we are going to cover volume first because I think it's the easiest part of this section. All right? You've got a formula sheet. Basically what volume is the area of the base times some height. So let's jump in. Let's do number 1. You have a roll of pennies. Okay? Roll of pennies. It's a cylinder. It tells you the diameter of a penny is 19.05 millimeters. Okay. 19.05 millimeters. That's your diameter. And the thickness is 1.52 millimeters. This is the thickness of 1 penny. All right. So they want to know the approximate volume of the roll of pennies to the nearest tenth. So I need 1 decimal. All right, so I'm going to take a quick peek at my formula sheet. I have a cylinder. So I'm using this volume equation. Volume equals pi r squared times the height. So there's a couple of things I need to do prior to actually plugging them in. First off, I need the radius. So I need to take the diameter, I need to cut it in half. So I'm going to grab my calculator, 19.05, not times, divide it by 2. My radius is 9.525 millimeters. Again, on these, do not round until the very last step. The other thing I need, the other dimension, the third dimension, is the height. Okay? I know that one penny has a thickness of 1.52 millimeters. Okay? So in order to get this height, how many pennies are in this roll of pennies? Thank you. Okay, so in order to get the height, I need to take the thickness of 1 and I multiply it by 50 pennies. Okay?
What page are we on? Oh, I see.
You got it? 1.52 times 50, 76. 76 millimeters is the length. All right, so now I have all the pieces of the puzzle that I need in order to plug in to my volume equation. So I'm going to sub in those things. My radius, 9.525 millimeters. I square that times the height, 76 millimeters. I already have 76 in my calculator, times, square that, times a pi, because it's a circle base. All right, so my approximate volume, remember we're rounding to the nearest tenth, is 21,661.7. And my units are millimeters cubed, because I have millimeters times millimeters. One of the things I put onto your volume or onto this formula sheet was I told you volume has 3 dimensions, so your units are cubic. So I may have centimeters cubed, feet cubed. So if I'm given a problem and I see the units are cubic or to the 3rd power, that's a hint that I have a volume. All right. So that's one dealing with cylinders. Let's do one that deals with prisms. Okay, so number 2, let's look at number 2. You have a prism of some sort. All right, your prism has a height of 8 inches, and a square base, a 14 by 14 inch base. And then you're also comparing this with a cylinder, okay? The cylinder height is 10, and your diameter is 10. And it says determine the difference, so we're going to subtract in order to find the difference between the volumes of these two things. Prisms, especially squares and rectangles, these are nice and easy. Length times width times height. So plugging in the numbers, 14 times 8. Let's plug that into the calculator and get the volume. 14 squared times 8. My volume is 1,568. Again, my units for volume are cubic. So, 1,568 inches cubed. Yeah. We'll zoom in. All right, now let's compare that to the cylinder. We just calculated some volumes for cylinders. The base is a circle. So here's my area equation for a circle. I have to multiply it by the third dimension, height. Now, the only catch here is they gave me a diameter, not a radius. So I have to take 10. Half of 10 is 5. You guys have that. All right. So now I can plug in my numbers. Pi, the radius was 5. I'll be good and I'll write my units. Times 10. So I get 5 times 5 is 25. Add a 0 because I'm multiplying it by 10. 250 times pi. All right, my volume for this cylinder is 785 point blah, 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 blah. I'm going to round to 4, but I'm going to keep this number in my calculator and use that. Again, it's volume. My inches are cubed. Inches times inches times inches. All right, so now I have to find the difference. That's easy. Big minus little. That's going to give me my difference. So, I'm going to take 1568, 1,568, and subtract the answer, which luckily my calculator saves. That way I get all those decimals, and I'll round at the very end. So the difference in volumes is 782.6 cubic inches. Oh, you guys can't see. The one with the pennies. The one with the pennies. All right, let's do one more, but on the back of this same page. Can I move it? Does everyone have that copied? You good to go? All right, let's do, on the back, let's do number 6. I love drawing pictures, okay? Especially for this section because it makes it easier. All right, so store salsa jars have a height. Okay, I'm going to draw a salsa jar. Don't have to be a good drawer. There's my salsa jar. Here's another example, even though it's a peanut butter jar. It has a height, H, of 10 centimeters. The radius of this salsa jar is 5 centimeters. Alright, it says if there is only 4 centimeters of salsa left in the jar. Uh-oh. Alright, I don't have red, so we're going with salsa verde. There's 4 centimeters of salsa left. This is on the back of the penny. Do you have it? It might look a little different. Flip on the back of that, or
It's number 5.
okay, you got it. Sorry, I think some of you have different pages. All right, so it's got there is only 4 centimeters left of salsa. And it says, determine how much salsa is missing from the jar. Yes, they tried to trick you. Okay, so your height that we're going to use is 10, the total, minus 4 that's left. So your height that you're actually going to use is 6. Good job, Ashton. We'll get you some bonus. All right. Volume is, it's a cylinder, so that's got that pi r squared times height. Let's plug some numbers in. Pi, the radius is 5 centimeters.
I like pi.
The height that I'm going to use is this 6. That's how much is missing. So plug that in. 25, that's 5 squared, times pi.
I like pi.
All right, they didn't tell me how many decimals to use. I like to default to 2. All right. So if they don't specify, oops, I do 2. So that's how much space there is in the jar. So to these problems, there's a common sense factor. That's right, I wrote it up there on the board. Make sure you pay attention to what they're asking. Pay attention to the question.
You need to remove your computer cart. You need to move it to somebody else's room.
Here's the lock. Here is the lock. Somewhere. You're welcome. Awesome. Okay, so that's all we're going to do for volumes of cylinders and prisms. So move on to this next sheet. Or sorry, yeah. We're still doing volumes, but in this case, we are not doing prisms and cylinders. We are doing pyramids and cones. I'm trying to post it on YouTube so that you can watch it again. Alright, so let's see which problems I picked for this one. I like number 2. Alright, we're going to do number 2.
You're going to put this on YouTube?
So, for number 2, it says, in 1483, Leonardo da Vinci designed possibly the first parachute in the shape of a pyramid with a square base. Okay, so I'm going to draw that, because that's what I do. Representative 3D figure right here. Alright, here's also a square pyramid. So let me plug in the numbers. I know it's a square base, so 12 yards by 12 yards. And then it tells me the height is also 12. Okay, what they mean by height, and this is important as you shall see, the height when you're doing volume is the height of the actual figure. Okay? Not this slanty height. It's not that height, it's the actual height from top to bottom. Okay, make sure you make that distinction, otherwise you're going to get this problem wrong. Okay? So, we have a pyramid. Let's look at the formula, which is right up here. Your volume is 1/3 the base height, or sorry, the base area times the height. B is base area. We have a square base. So the area for a square is length times width or sides squared, since they're the same. And again, this fraction, this 1/3, is because it gets skinnier as it goes up. It's to account for that skinniness. If you don't put the 1/3 in there, you just have the volume of a prism. A prism, all right? Because you haven't accounted for getting skinnier as you go up, all right? So make sure you throw that 1/3 in there. All right, let's plug in numbers. Volume, 1/3, 12 yards. Square that. 12 times 12. Times the height. All right. Time to plug it in.
Why would it be square?
Because it's a square base, so these two sides are the same. Good question. You can always do 12 by 12 times 12, if that helps. But we know in this case it's a square. So, I have 12 squared times another 12 times 1/3 to account for that getting skinny. So my volume is 576 yards cubed. So there is a pyramid for you. Calculating volume. All right, we would also like to look at cones. Think ice cream cones. There aren't a lot of real world examples. But the next one, number 3, is a cone. So we're going to do that one. Number 3. You have Monica, who sells lemonade over the summer, and she uses conical paper cups. This was like a big thing in the 90s. Water fountains and conical cups. Okay, all right, golf courses still use them. All right, each cup is 8 centimeters in diameter, so I'm going to go ahead and label that. And the diameter, or sorry, the height, meaning the height of the whole figure, not the slanty height, the height from top to bottom, is 11 centimeters. Okay, they also tell you she starts with a 10-gallon container. Ooh. Cooler container. 10 gallons. And they give you a conversion factor. Hint. All right. So what part A wants you to find, how many paper cups are needed to empty the entire 10-gallon cooler? Okay, well, first thing I noticed is I have 2 different units. Also, they gave me a conversion factor, which is a hint. You have to convert it to centimeters cubed. Otherwise, you're comparing gallons and centimeters cubed, which makes no sense. Okay? So my first step is to convert these gallons to cubic centimeters. One thing that Geometry Nation does really good, or I like, is they convert things using unit analysis. So those gallons are going to cancel. All right, I cancel the gallons because the gallons go on the bottom, and I'm left with cubic centimeters. 10's easy to multiply by, right? Because I just throw a 0. So I figured out the amount that is in the cooler. My cooler volume, if you will. So next I need what the volume is of 1 paper cup. I need to calculate that. All right? So then I can divide it out. So, volume for a cone, it gets skinnier, so it's got that 1/3 factor. Pi, because there's a circle. The base is a circle, so that's where the pi r squared comes from. And then you have a height. So basically, it's like a cylinder, but it gets skinnier, so that's why you do the 1/3. Same as a cylinder, but you do the 1/3 because it gets skinnier. So let's plug in the numbers. 1/3, that's a constant. Pi is a constant. My radius, they didn't give me a radius, they gave me a diameter. My radius is half that. And my height. I can plug it in. 1/3 pi times 4 squared is 16, so I'm just going to put 16. Sorry. 16 times 11. I get my volume of 1 cup is 184.31-ish. It goes on, and I'm going to leave that in my calculator because I don't want to round until the very, very end. All right, so to determine the number of cups, I'm going to take the volume of the cooler and divide by the volume of 1 cup. So the cooler has 37,850 centimeters cubed. And I'm going to divide by 1 cup. Again, I left all those decimals in my calculator, and that's the number I'm going to use. Thus the ellipsis. All right, so let's do it. 37850 divide by the answer I just calculated. That's the cup volume. So I get approximately 205.36. All right, here's the common sense factor. What the question asked was how many paper cups are needed to empty the entire 10-gallon cooler. If you put 205.36 blah blah blah, your answer is wrong. Because you can't have 0.36 blah 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 cups. Okay? So what they're looking for is for you to go, okay, in order to empty, I'm using 206 cups. That's your answer. If you stop at 205, there's still a little tiny bit left in your cooler. So make sure you think about what they're asking and you do that. You round to whole numbers when necessary. So we've done a cone and we've done a pyramid, so let's move on. We're going back to prisms and cylinders. We're going back to prism and cylinders. However, this time around, you're not doing volume, you're doing surface area and lateral area. In the top drawer. Okay. So let's go. Let's go. All right. Let's do number 1. So, it says for number 1, the average bedroom in an apartment is approximately 16 by 10 with an 8-foot ceiling. So I have a room. I have a room. We're on the back. That one with the tent. The one with the tent, guys. I have a room. My dimensions are 16 by 10. Those are in feet. And the ceiling is 8 feet high. All right. And it says, as an interior decorator that loves the 1970s decor, you need to cover the walls with groovy flowered wallpaper. Okay, so we're talking about wallpaper. So are we going to wallpaper the ceiling and the floor? When you wallpaper, do you wallpaper the ceiling and the floor?
Yes.
You could, but you're not. Okay, most people don't, so we're going with what most people do. So what we're looking for here is lateral area. Lateral area, meaning the different sides, not the top and the bottom. So surface area would be all these spaces, green, blue, pink. Yeah, it is actually purple, but on the screen it looks blue. So if this were our representative room, we're not going to do the top and the bottom, okay? So again, the reason we looked at nets is because I like to think about these using nets. Those 2D representations of the 3D object. Okay. So, I'm not including the ceiling, I'm not including the floor. So, I have 2 rectangles, this side and the back. You guys see that? Those sides. These rectangles, which are blue, they're congruent, right? I have 2 of them. Their dimensions are 16 by 8. So, I'm going to set up 2 sides. The area of those 2 sides is 16 times 8. I'm going to plug that in. 16 times 8, and I have 2 of them, so that's where the 2 comes from. That's going to give me the surface area of those 2 sides. That's 256 feet squared because it's area. All right, switching colors, my other wall is this side and this side, which you cannot see. They're absolutely congruent. So, like I did with the last one, I'm thinking about my net. The dimensions are a little different. It's 10 by 8. 10 by 8. So, 8 by 10. 8 times 10 is 80. So the area of those 2 sides is 160 square feet. So the total lateral area, because again, we are not including the ceiling and floor because we aren't wallpapering those. I'm going to add the 256 to the 160. And I get a total lateral area of 416 feet squared. So that answers that. That's how many feet I have to cover. But that wasn't even the question. the question says if one roll of wallpaper covers 50 feet squared, then determine how many rolls of groovy flowered wallpaper is needed to cover the apartment bedroom. Okay, so I need that. I still need that lateral area. My lateral area was 416 square feet. I need to know how many rolls of wallpaper, and one roll covers 50 square feet. So, taking 416 dividing by 50 should give me my answer. I need to buy 8.32 rolls at minimum. Oh wait, can I buy 0.32 rolls? No. So how many rolls do I need to buy? 9. Am I getting obnoxious yet on the hitting on the common sense thing? All right. So it's working. So, common sense. I can't buy 0.32 rolls. I have to buy 9 whole rolls. I can only purchase whole rolls. Keep that in mind. So really, that's your answer for part A. You have to buy 9 rolls. Cool. All right, moving on. Then they tell you for part B, if one roll of paper costs $15.90, then determine the cost to re-wallpaper the apartment room. All right, I have to buy 9 rolls. I know each roll costs $15.90. Rolls cancel. 9 times $15.90 is $143.10. That seems kind of cheap, but we are buying groovy wallpaper. That's the easy part. Alright, so again, that was a lateral area one, not a surface. Surface is all the faces, top, bottom, whatnot. Alright, number 2, let's do a cylinder. You have a fuel tanker's tank. Here's the tank. It's 50 feet long. 50 feet long and has a diameter of 7. And it says determine the surface area of the tank. Ooh. So surface area again is all of the sides. So if I draw a quick net of this shape, this is what a net of a cylinder looks like. This is a cylindrical net. Imagine this. We all agree that this is a cylinder, right? It's just missing those top and those bottoms. I'm going to cut it to show you. When you cut this paper towel roll and you unroll it, it makes a rectangle. You guys see that? Okay, so that's this part cut, opened up, and then again it's a fuel tanker, so in order to hold everything in, it needs a top and a bottom, which are round. Okay. So what we need the area of the 2 circles plus the area of that rectangle. Okay? We know the height of this rectangle, this side, is 50 feet. I know the diameter is 7, so what that means is my radius is 3.5. So I'm going to use that for the calculations of the 2 circles. Alright, I have 2 circles. I know the area formula for a circle because I had to memorize it, and you do need to memorize this. This is not given, okay? The area is pi r squared. R in this case is 3.5. Now what I need is to add the area of the rectangle. I know one of my dimensions is 50. Who can tell me what this is? Ooh, this is kind of, yeah, but what is it going to be numerically? Grace. Grace is getting points because she is totally right. This is the circumference. Okay, here's my rectangle, former paper towel holder. The length of the base of the rectangle is the circumference. All right, so times 2 pi r, which is 3.5. Sorry, I'm cramming everything in here. All right, so now it's just a matter of plugging everything in to my handy dandy calculator. 2 times pi times 3.5 squared. That will give me the area of the two circles. And then I'm adding the area of the rectangle. 50 times all right, so my surface area, again, area has two dimensions. My surface area is 1,176. Did they tell me how many decimals? No. So I'm going to go with my go-to, which is 2. Square feet. Again, this was just the container part, not the fuel. Surface area covers just the container. That's your analogy. Not the container and the stuff. Okay. Yeah. All right. Let's do number 5. So scoot over. Can I move this? Let's do number 5, which is on this side. Move my props. All right. So number 5, it says you have a can of sweet peas. So you have some cylinder. There's my can of peas. The radius is 1. And my height is 2. They want to know how much paper is used for the label. Oh, okay. So this is a lateral area 1 for a cylinder. So again, I'm going to draw my net. I already showed you why I drew a rectangle. But since we're doing lateral area, we don't have to worry about the top and the bottom. When you have a label on a can, you're not labeling the top of the can or the bottom of the can, right? And we're going to go ahead and assume that there's no space, okay? This is part of the label. The label goes from top to bottom. Okay, so my height is that. I still need the circumference, right? Because that's how I get this dimension. So I know my radius is 1. So 2 pi, the radius is 1. So really it's just 2 pi. All right. So my lateral area is 2 inches, that's the height, times the base, or the circumference in this case, 2 pi r. My r is 1, so it's just pi inches. So really I have 4 pi. If they wanted an approximation, I would plug this into the calculator. 4 times pi gives me 5.7 inches squared. Boom. Done. Does that make sense? Surface area, lateral area of cones and prisms. Or not cones, sorry, cylinders and prisms. Let's move on to cones and pyramids. Does everyone have this? I can change. We're going to go to the sheet, the next sheet, which has the roof on it. The roof. Yes. All right, so this is dealing with surface area, lateral area of pyramids and cones. I broke it.
What was that?
Don't die.
What was it?
It was just a ring holder. Dang. Oh well. It's ceramic. Okay, so let's start with number 1. Let's start with number 1. You have a roof, and it's a square pyramid. So the bottom is a square surrounded by triangles. It says the length from the gutter to the top. So that's what this dashed line is showing. The gutter to the top is 15 feet. So what that's showing you is what I called earlier, the slanty height. Remember when we were doing volume, I said use the height of the figure. When you're doing surface area or lateral area, you are using the slant height. Slant height. I like to call it slanty height. All right, so the slant height, which we also label L. So if you see that on your formula sheet, L, that means slant height. All right, they also tell you the length of the gutter. On one side, what I'm drawing pink, is 18 feet. And it's a square pyramid, so I can extrapolate that this is also 18. Okay? And it tells me 1 bundle of shingles covers 25 square feet. How many bundles should you buy? Okay, so what I need, I'm roofing. I need the lateral area because when I do the roof, I don't care about this square bottom. So I'm not including the square bottom. I'm just worried about these triangles. Okay, so what I'm going to do, will someone, awesome. Here's my net. Oops, can't see it. There's my net. Oops. Oh, okay. We'll tell him when he comes back. So I'm just roofing. I don't need to worry about the square base. I'm just doing the 4 congruent triangles. 4 triangles. Okay, so the area, remember we're doing lateral area. So for a triangle, area is 1/2 the base times the height. That's why they give you this slanty height, because it's the height of the triangle that you need. Slant, yeah, sorry. I like to say slanty, so that's what I'm going to go with, and maybe you'll remember it on the test, and you'll go, anyway. Fair enough. All right, so my base is 18. 18. My height is 15. So one triangle is...
Oh boy, you're going home.
No, that's not him. The base is 18. The height is 15. So plugging in to get the area of one triangle, I get the area is 0.5 times 18 times 15. The area of one triangle is 135 square feet. Again, I have 4 triangles, right? It's a square base, 1, 2, 3, 4. So I'm going to multiply this by 4 to get all the triangles. So the total area that I need to cover is 540 feet squared. But again, what the question wants to know is how many bundles do I need to buy to cover the roof? And they gave me this sweet conversion factor. So if I have 540 square feet and I know one bundle covers 25, I can take 540, divide by 25, and I get 21.6 bundles. All right, here's where I get annoying again. Can I buy 0.6 bundles at the store? No, so thank you. I need to buy 22 bundles. Boom, that's my answer. If you put this, you're wrong. FSA will mark you wrong. Don't do that. Don't fall for that trap. Think. All right, next question is a... Oh, sorry. You're welcome. All right, let's see how much we have left. Yeah, we do. All right, so we're going to skip that one. We're going to skip to the back, and we're going to do a cone really fast. Yeah, right. All right, let's do number 8. Number 8. It's a cone. They want the surface area. Okay. So another way you can think, another real world example of a cone is like a party hat, right? So if I cut that party hat and made it into a net, it would look something like this. Sorry, this is meant to be more curvy. Sorry about that extra line. Here, I'll shade it. This is me cutting the party hat, and then let's pretend it has a top. Okay, so that's a net of a cone. Top, bottom, unrolled, 2 dimensions. So what I want, in order to get the surface area, I need the area of this thing, and I need the area of the circle. I need both parts.
It looks like you turned down the volume on your computer.
Okay. So, it tells you that the diameter of the cone is 12 centimeters. And the slant height, meaning this dimension right here, this dimension that's green, is 85 millimeters. Here's where I get annoying. See how you have millimeters and you have centimeters? You can't do that. You need one type of units.
Then you gotta convert either. I would probably convert the centimeters to millimeters.
I'm going to do the opposite.
Well, if it's easier to do.
Yeah, do whatever. Okay? I know that 1 meter has 1,000 millimeters and 100 centimeters. Okay? So I'm going to convert to centimeters so that we don't get, you're checking out, so that we get smaller numbers. Okay? So, essentially what I'm doing is moving a decimal place. So, this is 8.5 centimeters. If you don't believe me, plug it into your calculator. Alright, I've done this one. I cheated. You're essentially just moving the decimal one place. Alright, so now that our units are consistent, I'm going to think about this for a hot minute. I know I have a circle. I want the radius for area. I don't want the diameter, so I'm going to go ahead and say the radius is 6 because that's half of 12. And again, we're doing surface area. So this, we need this. And what this is the circumference again. So this length is 12 centimeters. Alright, that red, this whole thing is the circumference. It's 12. And we're doing surface area of a cone. So here's my cheater formula. It's the area of the circle, pi r squared, plus the area of this weird curvy shape. Okay? So it's pi times r. So, pi times r. Pi, r is 6 times. We want to use that for this dimension. It's like a triangle, so that's where the r comes instead of the your height, your slanty height. Okay. So, my surface area is pi RL, meaning slanty height, plus pi r squared. Let's plug in numbers. Pi is just a number. R is 6. L is 8.5 because we converted it. Plus pi again times 6 squared. I'm going to plug all that into a calculator and get an approximate number. Start a parentheses, pi times 6 times 8.5 plus pi times 36, because 6 times 6 is 36. Enter. I get approximately 273.32. Again, they didn't tell me how many decimals, so my default is 2. And it's area, so my units are squared. Area units are squared. 2 dimensions. It's the container, not the container plus the stuff. That's volume. All right, moving along. Crushing it. You have this sphere one. They give you this sphere volume formula on the FSA. They do not give you surface area, 4 pi r squared. Those are your 2 formulas for this worksheet. So, we're not going to do one because they give you a radius and you just do this. That's too easy. Alright, we're skipping 1 and we're going to number 2 because I'm going to... Alright, it tells you that you have a sphere. Here's my representative sphere drawing. It has a diameter of 4 times x plus 3 centimeters. And the surface area is 784 pi centimeters squared. And they want you to find x. Okay. So what they've given you here is some complicated algebra, and they want you to solve for x. All right, so let me just copy my surface area formula. It's 4 pi r squared. So you have it in front of you. So I have this surface area, right? That's the 784 pi, blah, blah, blah. And I want x. I don't really have a radius. I have the diameter, so I'm gonna get the radius by dividing by 2. So my radius is actually 2 times x plus 3. So now I have both pieces of the puzzle, so I can plug it in and algebraically solve this for x. 784. That was the surface area they gave you. Plugged in. All right. 4 pi, that's just constants. That's just numbers. Easy. And then the radius. Ooh. 2 times x plus 3. That whole thing has to be squared. All right, so let's get rid of this 4 pi. Okay, let's get rid of that. Divide both sides by 4 pi. When you do that, what's left? The pi's are going to cancel, so I need 784 divided by 4. That leaves me with 196. And then I have 2 times x plus 3. That whole thing is the radius, so I have to square that whole thing. Okay, see how the algebra looks pretty ugly here? It looks pretty ugly. So if you get something like this on the FSA, here's what I want you to do. See how this is to the second power? Let's see if this is a square, if this is a perfect square. So I'm going to take the square root of 196. See how it's a perfect square? I can alleviate some of this mess by taking the square root of both sides. All right, so 196 is actually 14 times 14, so it is a perfect square. And now what I'm left with is this. Oh my gosh, I just saved you about 10 minutes of annoying algebra. You're welcome. Okay, so let's clean this up and solve for x. 7 equals x plus 3. X equals 4. Done. Easy. Easy. So if you see something really complicated, try and find a simpler solution. Okay? That'll save you time. But if not, if you had gone through all the steps, that's fine. It just would take you a little bit more time. Boom. Done. Got that? Take the 5 seconds to test this. See if it's a perfect square, or that might be, even if it weren't a perfect square, if it were decimal, it would have saved you time. Okay. Moving on, I think we're going to skip the rest of this. Also, on the back side of this, I just wanted to point out this is a trash question. You can write that if you want. The problem is it's too vague. So hopefully you get a couple of these on the FSA, because they tell you that you have different types of balls and different types of in a package, but they don't specify, is your package a cylinder? Is it a box, meaning a prism? All right, this is a terrible question. So anyway, moving on. It's a trash question. All right, let's go to the very last. I'm skipping this one and going to this one, because this one's another visual, easy breezy. We're going to get through it super fast. I'm going to borrow this awesome Oreo box, but instead of making it into I'm making it into a triangle. So for number 1, you have this shape. You have a 3D. You have a 3D prism. And they're asking you if you look at it from the top down. So, we all agree this is a triangle. It's a prism because it's mostly rectangles. There's 3 rectangles and only 2 triangles. I'm looking at it from the top down, and I'm going to flip it so you're looking at it from the top down. What one do you see? A, B, C, or D? Look at this. A. Yes.
Apple.
Some people say C. It's not C. If it were C, these would be cut in. And it's not B. B's the bottom. B's the bottom. These would be cut in like this. If it were C, that's why you would see like triangles. Okay? Done. Alright, let's also look at, oh my gosh, 10 more minutes. I'm not going to finish. 10 more minutes. Alright, let's also look at number 3. You have these shapes and you're cutting into them. Okay? You're thinking about sawing along this plane, making 2 shapes. What are you going to see? So I'm going to draw. If I cut this one along that plane, what shape are you going to see? What shape is this? Imagine cutting. I would go with rectangle. I know it does kind of look like a rhombus because of the angle. But you're sawing along a 3D shape. So if I cut the top off of that triangle, flip it up, what you're going to see is a flat top, and it's going to be a rectangle. Alright, so for part B, you have a prism, and they've sawed off one of the sides here. This one's the trick. They've sawed off one of the sides. What shape is that? It gets skinnier as it goes up. Who said it? Someone said it. Yes. It is. It is a trapezoid. Alexis. Trapezoid. Alexis. Bonus. Bonus. Trapezoid. Alright. I've got this triangular prism. I'm chopping the top off. We'll do this pink. And I get something that looks like this. What shape is this? Yes, rectangle. Now, had they said something, like had they given you more information like that, it's congruent to that, maybe it should be a square. But they would have had to give you that. They did not. Alright, and again, this is why it's got this green line. I've sliced down this green line. And what shape is left? Yes. Yes. This one's a triangle. Cool. So these are fun because they're more visual. Alright, I do want to touch on one of these last problems. I was going to go to Khan Academy and show you guys a video of a triangle rotating around an axis. Okay? When you rotate a triangle, a 2D triangle around an axis, it forms a cone. Okay? A cone. So we're going to skip and do 5 because 5's easier because it's volume. what they tell you on number 5 is you have this triangle. It creates a cone. When it's rotated about the axis RU. So this is my axis that I'm rotating it around. And then they want the volume of it. Okay, so 3D, when I'm rotating it, I get a shape kind of like this. All right? My volume equation for cones, there's that 1/3 because it gets skinnier. Pi r squared, because it's a circle base, times the height. Again, height. All right, in this case, we're doing volume. So we don't want slanty height. We want height of the figure, so top to bottom. So here to here, this is the height that I want. All right, I'm going to make that green. This is my height. All right, my height is the green one. All right, now the only problem is, oh no, they only gave me the hypotenuse. But this is a great question, and the reason we're doing it is because a review of right triangles. Remember, this is a 45-45, so it's also isosceles. And do you remember when you learned right triangles, you had this interesting shortcut? Ugh, yeah. All right, so because it's 45-45, this ratio happens. Okay, so I can take 18 and I can get my radius, which will also be my height because it's isosceles. I know. So I know my hypotenuse is 18. If I divide my hypotenuse by the square root of 2, I get an irrational number, which is not allowed. So I have to multiply it by 1 to get rid of that square root of 2 in denominator. Easy enough, bear with me. So that times that is 2. We still have 18 on top times the square root of 2. All right, this simplifies, and you're left with x, or the radius and the height is equal to 9 times the square root of 2. Oh my gosh, that just made this problem so much easier because those are equal. So now I'm ready to plug in up here this. All right, so let's do that on this side. My volume, it's a cone, so it gets skinnier, so that's why that 1/3's there. Pi is just a number. Radius is 9 times the square root of 2. I square that. And I'm going to go ahead and write another 9 times the square root of 2 because that's the height. This is the height. This is the radius. All right. But when I plug it into the calculator, I'm going to save myself some time. 1/3, that's going in there the same. Pi goes in there the same. All right, on this one, I'm going to say 9 times the square root of 2 to the, did I go over caret key with you guys? Caret key? That takes it to any power I want. I have 3 of these, 1, 2, 3, so I'm taking it to the 3rd power. All right, so my volume of this cone that was made by rotating around the axis is 2001 59.24. Again, that's my thing. I like 2 decimal places. They didn't give me units, so I'll just say units cubed. Wow. Wow. And then I'm going to stop there because the bell's going to ring. All right, so the reason I recorded this is I plan to post it on YouTube. And the other stuff that we didn't get through, I am going to work through the select problems and post them on YouTube for you guys. Alright? Search my name. It's got my picture. You'll see like a very professional collared shirt picture.
Well,
Yeah.
congratulations.
I'm going to link it to my LinkedIn also. That was a lot. That was a lot. Did everyone see where they're testing? That's all this is. So, I may or may not see you. One last announcement. Bring all those worksheets that we've been working on so I can send grades to Simpson. I'm just checking that you copied what I went over. Easy points.
Wait, are you even taking grades?
I'm going to send her a spreadsheet at the end of this week. I know you've been absent. We'll work.
I've been absent like once, but like,
yeah.
well, I had honestly speak, but also
Just
she
bring
hasn't been
everything you
here.
got. Alright, guys.
You know, I don't care, I'll figure that out.
Yeah. Don't worry. Don't worry about it. Thank you for your patience. Hopefully you remember my annoying reminders. Tell the 2A kids that I plan on posting that stuff on YouTube also. It might benefit them.
Where's it going off? Find it.
Just search my name, Tiffany Harmer.
Thank you very much. Have a great day.
Good luck on MSM. I don't see you.
I don't know, but there's a beautiful drawing on that paper.
So all the worksheets we've been working on, I'm going to just put I'm going to talk to her and we're going to give you 5 points apiece or something. So I have a bunch of copies too, just so that you can get some grades in the grade book for the time that I've been here. Okay? So just bring all the papers you got. If not, it's not a big deal because I probably have extras and I'll just give you that and you can copy